Hello and welcome back to the Fullerton College Pre-Press Lecture. This is Professor Ben Hewitt, and we are looking today at gravure printing processes in PIA's 5.1 reproduction processes. So gravure is what they use to print US money. Fair warning, I'm not totally sure how legal it was for them to reproduce this $20 bill in their book, even at small scale or on the slides. I'm gonna have to move away from this quickly. But anyways, you're not supposed to reproduce it, even in photos. You're not supposed to print it. That gets you in heaps of trouble very quickly. And as your instructor, allow me to say that we don't even joke about that in my classes. That will get our class shut down and potentially land us all in federal prison. Also, I should let you know that if I find out anyone is trying to reproduce money using any of our processes or class equipment, that I will personally turn you in. We're friends, but we're not, I'm going to jail for you, friends. Also, I do have family members in the Secret Service who specifically monitor that sort of crime. It is one of their purviews. So I have a direct line of communication for turning you in if I find out about this. Like I said, I'm not going to go to jail for you. Although I would like to consider us friends. That's going a bit far, don't you think? So anyways, Gravure is most known for printing money in the US. That's its most famous purpose. But it also prints things like high quality images for high quality magazines and some very good packaging. If you ever have packages with very, very high image quality, it was probably done on rotogravure. Things like National Geographic magazines, which have the most amazing print quality of any publication. My gosh, they have gorgeous quality printing. Use gravure because gravure gives you absolutely extremely accurate fine details. Also for things like fashion magazines and luxury magazines that show a lot of close-ups of jewelry, you can use such high resolution images that you get such perfect control over the color and such perfect edges. Oh my gosh, guys, seriously, gravure is wonderful. Unfortunately, we don't teach that at school here because it is unbelievably expensive to produce. Also, we don't want people trying to make money, but more importantly, the setup cost and the learning curve are both very high. In order to do well in Gravure, you have to already be doing well as a printer before you can even start learning this. In Dungeons and Dragons terms, it's a prestige class, not just a class. So anyways, it's also called Intaglio, the Italian word for it. Basically, it's the Newtonian reaction to letterpress. In letterpress and flexo, you have raised image surfaces that the ink sticks on top of. In gravure, you etch into a flat piece of metal and you fill up the metal, kind of like little cups, little cells of little cups of water, little cells of ink below the surface. And the ink rests in these little cups. And it pre-measures the amount of ink per cell, which is one of the reasons it is so accurate and so consistent. But that means that every printing plate is an actual etched metal cylinder. Hopefully, if any of you understand how expensive things are out there, and if not, I'll just tell you, take my word for it, this is probably starting to sound kind of pricey once you start doing these sorts of things. Here's a good picture of it. So these cells, these recessed areas in the surface, hold the ink. You can actually hand etch them, and they do that for like the portraits of the presidents and famous people, because Franklin was never a president. Uh, little known fact, Benjamin Franklin was never a president in the United States, just an ambassador and all around cool guy. Uh, anyways, so those things can be hand etched. You can sit there with a metal stylus and actually scratch the surface of a plate and hand draw an image to be done in Taglio. So the ink stays down in the cells, and there's a doctor blade. Doctor blades exist on other systems as well, but the doctor blade scrapes the surface so that nothing is left on the non-image areas, only down in the little tiny cells that hold the ink. And then the ink gets transferred to the substrate through pressure, just like everything else. But this has a much higher quality image. The pre-measured amounts of ink allows for very little dot gain, very little slop, very little spread out. It all just goes exactly where it's supposed to go. Again, why they use it for things like high quality magazines. For money itself, if you ever look at a dollar bill, of course I just say a dollar bill. Some people would say $100 bill, but you'd have to have one of those to talk about it. And I'm only a teacher. But anyways, You look at money under a loop, under a magnifying glass, and the level of detail of those fine lines is absolutely exquisite. These little tiny spider webs in the corners of things, all used for anti-counterfeiting to make it much harder to make copies of. But man, just as an art, it is gorgeous. Rotogravure, it can also be used using a little bit of electrostatic charging, where you will actually ionize the cylinders and ionize the ink, because as we know from our clothes dryers, if you charge things with the right type of electricity, they stick to each other and you have to peel your socks off your pants, right? But anyways, uh, the same type of thing, if you charge the ink one polarity and you charge then it looks like in this image, they're actually charging the, what's it called? The impression cylinder on the other side of the paper, the opposite, then that attracts the ink and it hits the paper, which is in between them. And it helps transfer the ink directly across. Again, very accurate, very consistent. And in printing, consistency and repeatability are our game. More so than accuracy. It's more important to print the same thing every time than it is to print the right thing once. One perfect print does you no good. A million pretty good prints is fantastic. The Gravure process, here's a sample. You can kind of see the shapes of the cells if you zoom in really close. And this is a much closer magnification than we had when we were looking last time at the letterpress and flexo samples. They were farther away. So if you ever see those kind of diamond-shaped pixels going on, you know it was done by Gravure. You might also just notice that the image is unbelievably beautiful. That also typically means it was done by Gravure. So the advantage is it's super consistent with super high accuracy and super fine detail control. But it's so expensive to set up. You have to produce those metal cylinders. And I know we haven't talked about it yet in this class, but to print normal photographs, you have to have 4 image carriers to make one picture. One for each of the primary colors, cyan, magenta, yellow, and black, to be able to produce the normal range of colors. More if you want to use special colors like Coca-Cola red or other spot colors. So this is getting really pricey. So you have to make 4 expensive, sometimes handmade cylinders, sometimes machine made, but still the entire cylinder has to be thrown out, or I guess saved. It's consumed in the process. You can rerun it later. So that means you have to run enough things to make it worth your time. So if somebody comes in and they want to print a half a dozen business cards to give to their friends, it's not going to be rotogravure. That means they're going to be spending hundreds or thousands of dollars to get a half a dozen cards in their pocket. But if you're doing something like, I don't know, National Geographic, where you're producing millions of copies and sending them all over the country, then yeah, that's a great idea. And if you're doing something like money, where you're producing millions and millions and millions of copies of each of these bills and sending them all over the country, that's a great idea. They'll all be accurate, they'll all look great, and you're not wasting your effort because you're producing so many copies that you're going to make it, it's going to make up the cost. So long runs only. It is the least efficient as far as setup goes. Screen printing, one of the most accessible ones to talk about. A little bit out of order from how I would introduce screen printing first, as I do in 101, because it's the easiest one to understand. Screen printing, we all know it, we all love it. This is how you print things like t-shirts and tote bags and backpacks and stuff. It's also doing for other things, fabrics, glasses, wall coverings, linoleum, computer circuit boards. You know, the conductive metallic things in the back of a circuit board instead of wires, those are actually screen printed on there. Pretty cool, huh? Also product. I have a 3D printer sitting next to me, the Ender 3. It's a lower consumer model, but the logo is screen printed onto the metal. Go screen printing for being one of the most adaptable printing methods out there. Anyways, it used to be called silk screening. When I was a kid, my dad did it and he called it silk screening because for a while you would actually use literal silk to make your screens. So the whole idea is you have a screen mesh of fabric, and on top of that fabric, you have a, what do you call it, stencil of some sort. The stencil covers the non-image area. The stencil says no ink. The open parts between the stencil say yes ink, and you force ink through it. And because the mesh is porous, because you can push through this screen, the ink goes through, and you can have that design done as a stencil. And if anyone has ever cut stencils by hand, or you think of the old army style stencils that they paint onto things where the letters don't quite connect, think like the word stop in the road next to a stop sign when they paint the road. Those stencils have to have lines where the letters don't connect all the way because they're just big stencils. But if you have a mesh supporting your stencil, you can have floating elements and complete circles and things that you would never get in a normal stencil. Hooray. So the screen blocks the non-image. The ink goes between the screen through the mesh onto whatever it is you're printing on. And with screen printing, your guess is as good as mine. One of my great favorite stories of screen printing is the teacher who taught me to screen print back when I was an undergrad student. I was learning at Pasadena City College. Um, he was a screen printer who did a bunch of artwork for different bands. He did a lot of gig posters for rock bands. Cool guy. One of his jobs, he was telling us that he got hired to do stuff. When he gave them his resume, he screen printed his resume on the back of an old street sign and gave it to them. Not only telling him what he could do, but proving, yeah, I can do this. And to me, it's just like, yeah, print on a street sign. How cool. Uh, don't vandalize things, guys. I guess I should say that before this comes back to haunt me in the future. I am not inciting you to vandalism. I think he bought it somewhere. But anyways, the point is it can print on anything. Screen materials, there is multi and monofilament. Multifilament means you have multiple threads twisted together, kind of like threads you buy at a fabric store. Monofilament, for those who are not so nerdy, means that there's only a single strand, and that can be metal, polyester, nylon, even silk could be a single strand of silk to produce it. And this is better because you have a much higher degree of accuracy and it doesn't absorb any ink. The problem with multifilament is the gaps between those twisted things can soak ink up and become a problem where it wants to lay down extra ink and spread out, and it's just a mess. For those nerds out there, whenever I hear monofilament, I think about the book Dune, where they have monofilament knives, meaning that their blades are so thin. It's a single molecule. It's not quite that cool here, but it is cool. So let's talk about how you make these things real quick. They are not talking about all the different types of screen printing here because there's lots of different ways of making the stencils, including hand cut stencils out of paper and other materials that are glued onto a mesh. They're only talking about the modern photo emulsion system. And the photo emulsion system means you coat it with a chemical that is photosensitive, meaning if you expose it to light, it hardens. You put a film positive, i.e. there's ink where you want there to be ink in front of it, and you expose it to ultraviolet light. You can use an exposure table. You can go rent time on a tanning bed and make the tanning studio really angry with you. That's a joke, don't do that. Or you can sometimes even expose them using the sun and a stopwatch to give it the right exposure time. And the part of the emulsion that gets exposed to light, i.e. the non-image area, hardens. Then you wash it out with water and let it dry, and you have yourself a stencil. And you force the ink through the screen onto whatever it is you're printing on. Oftentimes it's t-shirts. Remember that just like other printing processes, the screen, no matter how many colors you're thinking of, no matter what color you're thinking about printing, the screen still answers that one question, and it's yes or no. And the question is there ink here? So if you want multiple colors, that means, you guessed it, multiple screens, one per color. It's either yes ink or no ink. The color of the ink you put on it is up to you. Here's the basics, showing a picture of what I talked about. The film positive shows the letter that you want to print in black. You need black to block the light. You have the light sensitive emulsion on the framed screen. The letter on the film positive blocks the light, and that part does not harden. Then when you wash it out, you have a hole in the shape of whatever your picture was. Then you can force ink with a squeegee through that onto, hey, look, a t-shirt. There are automatic screen printers. We have one that we're slowly fixing up in our lab we'll use eventually. These are used for large productions of shirts. If you see like screen printed t-shirts for sale at Walmart or Target, chances are there's not a guy in a garage doing this stuff guerrilla style, making his own artwork. Chances are there's a large factory somewhere in a warehouse where there's a machine that automatically pulls the squeegees for you and rotates the shirts through. And the only human interaction is either making the screens or putting the t-shirts onto the pallets to run. But anyways, the automatic screen printers speed things up for larger production runs. Doing it by hand is slow and labor intensive and very skill intensive to make a good print. So screen printing has its advantages and disadvantages, just like everything else. The greatest thing of screen printing is you can print on anything. I'm not saying you should and you'll get in trouble if you do, but you could take the screen off the stand, put it on the floor below you and print on that floor, and you've done it. I've seen a guy print on wagons for his grandkids in class, custom wagons. You can print on skateboards, surfboards, cars, t-shirts, backpacks, paper. I mean, honestly, you can make some really cool posters using screen printing. Literally anything that you can get the screen to touch. It makes a very thick ink film, which means it'll be a very durable product. You can wash the t-shirts and still wear them again and the ink doesn't come out. but it's hard to do small, fine details. So it's a bit of a coarse half tone that you're able to do. Don't expect to do a lot of process color and don't expect to do very accurate process color. Although I did once meet a guy from a screen printing shop going through G7 color management training with me, and he was using the G7 process to color manage screen printing. Way to go, man. Way to go.